Okay, so we've done the analysis so far, and we've recovered our winning positions, and now we've actually built up 2 new winning positions by pointing out that from 8, we can put our opponent on either 6 or 5, and both of those are losers. And from 9, we can put our opponent on 6, which is a loser. So now 10, 11, and 12, are they winning positions or losing positions? 10 and 11 are losing positions, I see. So do y'all agree with that? So why is 10 a loser? From 10, I have 2 options, 1 on 7. I'm taking away 2 or 3, but neither one of those is good for me. If my opponent starts at 8, I'm going to lose. My opponent starts at 7, I'm going to lose. And then with 11, it's the same damage. I'm going to take away either 2 or 3. Whether I put my opponent on 9 or I put my opponent on 8. Either way, now this is my opponent's move. So if I start here, then the next player is in a winning position where they can make me lose. Do you notice any pattern in terms of how these winning and losing positions are going? So 2 losses, 3 wins, 2 losses, 3 wins. And so our prediction, although we haven't actually done the complete argument yet, is that I would have win, win, win. Do y'all agree with that conjecture? Conjecture is a guess based on a pattern that I see. So now I want you to look at something with me. I have built this up a little bit painfully, painstakingly at least, because I wanted to be clear about how this type of analysis works. But now that we have done this analysis, I'm going to claim that we don't have to do this piecemeal anymore. Because I have seen a pattern, and the pattern is that this repeats every set of 5. Like 0 is a losing position, and then 0 plus 5, which is 5, is also a losing position. Do y'all see what I'm saying? And then 5 plus 5, which is 10, is also a losing position. And so I'm going to predict that 15 is a losing position. It is 5 away from a losing. Does that make sense? So I see this pattern that if I want to know whether or not something is a losing position or a winning position, I can just subtract 5. And this is related to an idea that I'm sure you have seen before called the remainder after division. So if I divide 15 by 5, I have a remainder of 0. And so what's really important here is that 0. And I can look at this 0 and I can say, wow, that 0 is actually what's important. It's crazy to me, but it's true. So I look at that 0 and I can go back and I can say, all right, 0 is the remainder after division. And that's what matters here. And I see that 0 is a losing position. So that means that if I look ahead, 15 will also be a losing position. So if someone asks me, so here's the fact, here's the theorem. We're not going to prove the theorem rigorously. We're not going to give the full, mathematical argument that a professional mathematician would give. I'm just going to tell you this is a fact. In this game, you can determine whether something is a winning or a losing position by checking its remainder on division by 5. You understand the statement that I'm making here? So is 253 winning position or a losing position? Well, I don't have to build the graph up piece by piece. To answer this question, I can just look at the remainder after dividing 253 by 5. And it turns out the remainder after dividing by 5, you can sort of get at by the last digit. So in this case, 253, the remainder after dividing by 5 will just be 3. And I can take that 3 and I memorized that 3 is a winning position. So 253 is a winning position. I'm using this remainder trick. Doesn't matter what game, how many objects are in the pile. If we're playing a game with n objects in the pile, and the moves are either take away 2 or take away 3, and we agree that when someone cannot move, they lose, then I can tell you whether I want to go first, and I can guarantee you that, so I want to go first if the number of objects in the pile has a remainder of 2, 3, or 4 on division, and my goal is to make sure my opponent always stays on numbers that have a remainder of 0 or 1. Now this game took us about 40 minutes to really deeply analyze in depth. And I could have taught you this rule in probably about 5 minutes. And if I were a person who wasn't very ethical, what I might do is hire an army or hire a group of people that I thought were charismatic and likely to get people's interest. And I might have them go make a killing at a bar playing this game against drunk people for $1 a game. Because I can guarantee that my people will never lose. This is a pretty simple algorithm that I'm confident they can execute. execute, and I can teach it to them. And we can practice it enough that they'll be able to do it. A situation where the other person is not experienced and maybe intoxicated or distracted by the fact that the people I hired are engaging. Now, I like to think of myself as something of an ethical person, so I would never do this. There are lots of games like this in the real world where the game is completely analyzed, and what someone is offering you, you actually have no chance to win. So that's why analysis of games like this is so important.